This is Jana Lecture, Assistant Professor at IT/ICT Department of LJ Institute of Engineering and Technology. Welcome to the first lecture of Unit 10. Unit 10 is about advanced topics in software engineering. Till Unit 10, we have learned about various phases of SDLC life cycle. That is about requirement gathering, requirement analysis, then designing, implementation and testing, then quality standards, then configuration management and DevOps. Now in today's lecture, we will learn about what are the advanced topics in particular subject, that is software engineering. So in this unit, we will learn about component based software engineering, that is CBSE, client server software engineering, then web engineering, computer aided software engineering, that is CASE, and about software process improvement. Okay, so let's start with the first topic of today's lecture, that is component based software engineering. So basically, component based software engineering is a process that makes the design and construction of computer based system using reusable software components. Okay, so for an example, if you are working in any organization and you have to develop the application that contains login and sign up, means registration related activity. So what you are doing, you will just develop a component of that login page as well as a registration page, and you are reusing that component in every application. Okay, so component based software engineering means it is a kind of process that makes the design and construction of computer based system using reusable software component. Okay, so once you have developed such kind of component, so you can reuse it once you need it. Okay, so it is an approach of defining, implementing, integrating loosely coupled independent component into the system. Okay, so CBSE seems quite similar to the conventional or object oriented software engineering, and it is basically a reuse based approach. Okay, so its name suggests itself like component based, means you are reusing components in your software product. Okay, so here is a kind of one structure that you have software system specification. Okay, so if customer will give you some requirement, so these are some software system specification. Based on this, you are decomposing the actual project. Okay, so what are the modules, which components you have to use for developing such kind of software. Okay, then you are identifying component specification, then search, modification and creation, and then after once all the components are individually developed, you are integrated them. Okay, so integration, and at last you will develop a software system. Okay, so that's the actual work product of your software. Okay, so as the time goes, you are covering all these things. Okay, so starting from system specification, then you are decomposing your actual project into multiple modules or components, then you are doing a component specification, search, modification and creation, then integrate all the components, and at last you will get an actual software system. Okay, so this is about the CBSE, that is component based software engineering. Now what do you mean by component? Okay, so basically a component is an independent software unit that can be composed with other component to create a software system. Okay, so for an example, if you want to develop a software like a library management system, okay, so components are like books, then users, okay, then librarian. Okay, so there are multiple components in your library management system. Okay, so technically, a component is a kind of small unit. Okay, so it is a software unit that can be composed with other component to create a software system. And as per the Council and Handman define a component as a software element. So both the software engineer define a component as like a software element that conform to a component model and can be independently deployed and composed without modification according to a composition standard. Okay, so if you are developing any component, so each components are developed individually, okay, independently. So you are developing such component or such unit independently, then you are integrated all the components. So integration of all the components are make a proper useful software product. Okay, so Council and Hinman define a component as a software element that conform to a component model and can be independently deployed and composed without modification according to a composition standard. Okay, so this is about the component. Now let's discuss about what are the characteristics of component. Okay, so basically components are independent, composable, deployable and documented. Okay, so independent means, as we have already discussed, each and every software product have multiple components, okay, and that particular components are individually developed. Okay, so a component should be independent. Then another characteristics are like composable. Okay, so it means that all external interaction must take place through the publicly defined interfaces. Okay, so if your one component is dependent on another component or it is integrated with other component, so all the external interaction must take place through publicly defined interfaces. Okay, so that is about composable. Then next characteristics is about deployable. Okay, so component has to be self-contained and must be able to operate as a standalone entity. Okay, so if you are registering yourself using registration page, you are logging into particular website by using a login page. Okay, so these are some different components. Okay, so a component has to self-contain and must be able to operate as a standalone entity. And the last characteristics about documented means if you are developing any component, so you have to define a documentation of that particular component, means what particular purpose of that component. Okay, so the component must be fully documented so that any user can decide whether particular component is useful to meet the system requirements. Okay, so if you are developing any component, so based on the documentation of that component, a particular developer can decide that that particular component is useful for the given system requirement or not. Okay, so customer will give you some requirement and based on that you are defining which component is needed to develop such kind of specification. Okay, so once you have done with component selection, you are documenting that component, so you can easily able to map the things like is whether that particular component is properly working or not for the particular requirement. Okay, so these are some characteristics of component. Now let's discuss about actual framework activities. Okay, so computer-based software engineering is a kind of framework activity. So for those requirements that can be addressed with available components, the following activities take place. Okay, so first of all you have to identify the qualification, means component qualification. Then another activity is component adoption, then component composition and component update. Okay, so this is the framework activity for the component based software engineering. So let's discuss each and every activity in a detail. So first is component qualification. Okay, so basically this activity ensures that the system architecture defines the requirements of the component for becoming a reusable component. Okay, so if customer will give you some requirements, so based on the requirement you are identifying the components. Okay, so which particular component need for that particular software requirement. Okay, so this activity ensures that the system architecture define the requirements of the component for becoming a reusable component. Okay, so if customer will give you requirement like I want a sign up page that you have already developed, so you are reusing that component. Okay, so reusable components are generally identified through the traits in their interface, and it means the service that are given and the means by which customer or consumer access these services. Okay, so which type of service is already given and how that particular customer or consumer are accessing those services. Okay, so that is about the component qualification. Okay, so the service that are given and the means by which customer or consumer access these services are defined as a part of component interface. Okay, so this is one of the framework activity in CBSE. Okay, so now another activity is like component adoption. Okay, so once you have decided about the component, you have to adopt that component for software product development. Okay, so this activity ensures that the architecture defines the design condition for all component and identifying their modes of connection. Okay, so how particular one component is connected with other component. Okay, so in some of the cases existing reusable component may not be allowed to get used due to the architecture design rules and condition. Okay, so if you have developed any application that have some private use, okay, for the private use, so you are not able to access those component in other application, okay, so that particular component are not a reusable component. Okay, so in some of the cases existing reusable component may not be allowed to get used due to the architecture design rules and condition. Okay, so these components should adapt and meet the requirements of the architecture or refused and replaced by other more suitable component. Okay, so if somebody asks you for such kind of information or such kind of component, then what you have to do, you have to refuse or replace that particular component so that you can easily adapt the other component for your software product. Okay, so this is another framework activity for CBSE. Now the next activity is about component composition. Okay, composition means you are dividing your component into a multiple sub-component. Okay, so this activity ensures that the architecture style of the system integrate the software component and form a working system. Okay, so individual components are there and you have to composite all the component in a working module. Okay, so this activity ensures that the architecture style of the system integrates the software component and form a working system. Okay, so by identifying the connection and coordination mechanism of the system, the architecture describes the composition of the end product. Okay, so how particular one page or one component is connected with the other component, that is mentioned in the component composition activity. Okay, and the last framework activity is about component update. Okay, so this activity ensures the updation of reusable component. Okay, so sometimes it demanding from the customer, like you have to update the version. Okay, so you have to update the component of that particular software product. Okay, so this activity ensures the updation of reusable components, and sometimes updates are complicated due to the inclusion of third party. Okay, that means the organization that develop the reusable component may be outside the immediate control of the software engineering organization that accessing the component currently. Okay, so for an example, if you are developing something and you are seeking help of any other engineer, so what you are doing, you have to give that particular component to the third party. Okay, and they will develop a particular component and deliver to the you. Okay, but then after few years you need to update that particular component, but that particular component is developed by another third party. Okay, so it is very difficult to collaborate with it. Okay, so sometimes updates are complicated due to the inclusion of third party. Okay, so these are the CBSE framework activities. So now let's discuss about what are the advantages of component based software engineering. So advantages are like it reduces the development time. Okay, so there are multiple component based software engineering techniques are available, so it reduces the development time of any software product. Then it increases the productivity. Okay, so number of production you can done by using a CBSE framework activities. Then it reduce in a cost for development. Okay, then it is reliability is increased, management of complexity and flexibility. So these are some advantages of CBSE, that is component based software engineering. It is flexible, it also reduces your development time, it increases the productivity for your software component, even it increase the reliability and also have advantages of management of the complexity. Okay, so if any complexity arises for your software product, then it can be easily managed by the component based software engineering. Okay, so this is about the component based software engineering concept. Now let's discuss another topic, that is client server software engineering. Okay, so as you have already know, what do you mean by client and software? So client is a kind of workstation and server is a kind of data source. Okay, so client means a client is a single user workstation that provides presentation services and the appropriate computing, connectivity and the database services and the interface relevant to the business need. Okay, so client are PCs or workstation on which user run application. Okay, so clients rely on server for resources such as like files, devices, and even processing power. Okay, and there are mostly two types of client, that is thin client and a fat client. Okay, so this is about the client, means it is a kind of workstation or your PC system. Okay, now what do you mean by server? So a server is one or more multi-user processor with a shared memory providing computing, connectivity, and the database service and the interface relevant to the business need. Okay, so server are powerful computer or processes dedicated to managing the disk driver, means your file servers, printers like print server, or network traffic, that means your network server. Okay, so this is about the server. Now what is the actual client server architecture? So client server architecture is a network architecture in which each computer or processes on the network is either a client or server. Okay, so if you have a system, so whether that particular system is working as a client or server, that is defined in a client server architecture. Okay, so it models the application in such a way that the server consists of a set of services which are demanding by the client. That means client demand for the services and server provide the services to the client. Okay, so if I write on a Google like www.google.com, okay, so I am a client for requesting a particular Google page, and from the server side it will display a Google page. Okay, so that is a server and I am your client. Okay, so this is the actual scenario. So the client and server are the separate process. In figure you can see that there are multiple clients are available, means any workstation or PC, and there is an internet connection, and another side it is a server. Okay, so let's discuss more about modern client server architecture. Okay, so for an example, if your result came and what you are doing, you are just checking for the website. Okay, so you are entering the website like www.gtu.ac.in, then result section. Okay, so here client server architecture is there. You are client, and on the other hand server is act as a data source. They have your result. So if you are entering correct details, it will display a actual result. Okay, so this is the actual scenario of modern client server architecture, where there are multiple workstations are there are terminals are there, and there is a network line. Okay, so all the client is connected with a network, and there are mainframe computer, then mini computer or a server. Okay, so on server side anything can be act as a data source. Okay, so this is the modern client server architecture. So what are the types of client server architecture? So basically there are two types of application: two-tier architecture and three-tier architecture. Okay, so basically high level we can say that two-tier architecture is client server application, and three-tier architecture is a web-based application. Okay, so let's discuss more about two-tier and three-tier architecture in a brief. So two-tier architecture means it is based on a client server architecture. Okay, so here one side there is a client and on another side there is a server. Okay, so the two-tier architecture is like client server application. Okay, so the direct communication take place between client and server. Okay, so there is no intermediate between client and server. Because of tight coupling, a two-tiered application will run faster. Okay, so you can see that if I enter google.com or any website or any URL, okay, so it will automatically redirect to the server and fetches some detail and give it to the client. Okay, so it is a direct communication between client and server. Okay, so this is about the two-tier architecture. Okay, so what is the example? So example is like the ATM. Okay, so automatic tailoring machine. So ATM is an example of two-tier architecture where the ATM is connected to the server. Okay, so if I am a customer, I will operate the ATM and the information is processed at the client side. And what happened, like the data management part is handled by the server. Okay, so if I am entering, like I have to deposit money or I have to withdraw money. Okay, so that is the client side process. Okay, and from our bank side, that is act as a server. Okay, so this is the basic example of two-tier architecture where there is a direct communication between client and server, means your ATM machine to your actual bank. Okay, so this is about two-tier architecture. Now let's discuss about three-tier architecture. Okay, so three-tier architecture typically comprise a presentation layer, application or a data access tier and server or data tier. Okay, so three layers in the three-tier architecture are like, first is a client layer, third is the server layer, and in between there is an intermediate level, that is application layer. Okay, so this is the diagram of three-tier architecture where you can see that there is a client application, so multiple PCs and workstation are there. Then there is an application server, it acts as an intermediate for communication between client and server. Okay, and there is a data source, means it is your actual server. Okay, so here application server act as an intermediate between client and server layer. Okay, so what do you mean by client layer? So it is also called as a presentation layer, okay, which contains a UI part of our application. Okay, so this layer is used for the design purpose, where data is presented to the user or input is taken from the user. Okay, for an example, if you are designing any registration form, okay, and which contains some text box, label, button, etc. information. Okay, so that is the client layer. Okay, so that is the presentation layer for customer. Okay, now what is the application layer? So it is like a middleware. Okay, so in this layer all application logic written like validation of data. Okay, so if you are entering your username and password, so that is a client layer, but whether that particular information is correct or not, that is the work of the application layer. Okay, so this act as an interface between client layer and server layer, and in this layer all the application logic written like validation of data, calculation, then data insertion, etc. are performed. Okay, so this layer is also called as an intermediate layer, and that help to make communication faster between client and a server. Okay, so this is about the application layer. Okay, now what is the server or data layer? So in this layer actual database is comes. Okay, so here actual database is comes in a picture. Okay, so data access layer contains method to connect with database based on our input data. Okay, so this is about the three-tier architecture. Now let's understand it by example. So example is like you are doing internet banking. Okay, so nowadays internet banking is commonly used. So internet banking is an example of three-tier architecture, where in this application the client browses the web page, okay, and requests for banking transaction. Okay, so that is your presentation tier, means your client layer. Okay, so you are requesting for any website for the internet banking, okay, for any bank website. Okay, then the application processes the request and communicate the database server to verify the request for transaction. Okay, so if I enter my username and password, it will verify with the database. Okay, so here application processing tier is in a picture. Okay, so it acts as a middleware. Okay, so once I have entered my username and password, it will validate my username and password, means whether the information that is given by me is right or wrong. Okay, so based on this it will display a messages. Okay, and the database server store the bank database and execute the queries. Okay, so the result of these queries are returned to the application server. Okay, so if I enter my username and password, it will be my presentation layer. Okay, then after it will validate my data. Okay, so whether my data is correct or not. If correct, then it will redirect me to the actual home page of my banking system. Okay, so that is a request that is given by the server. Okay, so that particular page is displayed by the server. Okay, so if customer will enter in particular internet banking by their own user ID and password, so application layer is in a picture to act as a communication between client and server. Okay, so it will validate, and where it will validate, it validate the actual data filled by the customer to the actual bank server. Okay, so in bank database there is an entry of particular customer, so server has some database, so application layer will validate all the details from the server and redirect to the again client layer. Okay, so this is the proper example of three-tier architecture, in which internet banking is a best example. Okay, so this is all about a three-tier architecture. So that's all for the today's lecture. In today's lecture, we have learned about component-based software engineering and about client-server software engineering. Okay, so that's all for the today's lecture. Thank you.